Voilà, soyez le bienvenu. This is Engineer Kanene. This very important lesson, we're looking at IPE steel sections and base plate connection. How do we connect steel to concrete? Okay, what are the rules? Okay, what are the some rules that we need to put into consideration? You as the engineer must have this information. So in this lesson, I'll teach you the types of steel sections. We're going to look at the gauging process for base plates, connections. We're going to look at RCC and how we do overlapping for anchor bolts. So follow along. So what is this connection we're talking about when we talk about steel and base plates and RCC concrete columns? What are we specifically looking at? So we're talking about this connection here. Okay, we're talking about this connection between this steel column that you are looking at here. This is steel, and this concrete column that you are looking at, which is reinforced. This is RCC, reinforced cement concrete column. So this column here is concrete and it has steel in it. How do we join it to this steel section here? This is the purpose of this lesson. Okay, so like you are seeing on the picture, you have a steel column. This is a steel column. I will talk about the types of steel sections for as we go on. So this concrete column is connected to a base plate. This metallic plate that you're looking at here is called a base plate. Okay, a base plate. So this base plate rests on what are known as anchor bolts. These are anchor bolts. So this diagram you're looking at has got 4 anchor bolts. 1, 2, 3, 4. And this anchor bolt is what anchors this base plate. Below this base plate here, this rectangular base plate that you're looking at here, below it there are also leveling nuts between under there. So you have got anchor bolts. These are anchor bolts. I'll talk about more or highlight more on how they are sold and made. Anchor bolts. These anchor bolts, below they have got nuts, these leveling nuts. Then on top you also have nuts there. Just below the nuts you have got washers there. So after the base plate, then down there, after this base plate is anchored or it is leveled on top of these nuts, then you have what is known as grout. Okay, this is a non-shrinking grout that is casted under there. Then from there you have now the concrete column there, the RCC column there. So there is the column. On top of it you have the grout, then you have the base plate, then the base plate is what connects the what? Is what connects the steel sections. So this is what we want to talk about in details, okay, in details. So when you look at the construction industry, you will see different types of connections or joints. For example, you have, this is a beam section connected to this column, okay? And there's this different type of connection that we have here. But the purpose of this lesson is not to look at these beam column connection. What we want to focus on is this column and steel column together with an RCC column there. I believe at some point, even for laymen, they have seen this connection before. And they always wonder, why is there a space between this metallic thing here, standing here, and this concrete? Why are they not just attached? Okay. And for a layman, they might not understand, but for we engineers, we must be able to understand that. So this is another type of section, steel section. This is not an IPE section. This is a different, what we call HSS section, which I'll show you in the next slide. So this is what we're talking about, this connection. You have your RCC column there, and you've got this steel section there. Then you have these anchor bolts. These are anchor bolts. Anchor bolts, and you have got here, these are nuts. Okay, nuts. Below the bolts, you have these washers. Then you have got your base plate. Base plate, under the base plate, you have got, again, nuts, leveling nuts. Okay, then the leveling nuts, then we have got this that is casted, which is known as what? Which is known as non-shrinking grout. Okay, non-shrinking grout. We'll talk about the reasons for all this. Then from there, then you have your column. So the base plate does not sit directly on the column, no, on the RCC column, no, it doesn't sit directly. And we'll have to answer why. Okay, so now types of Steel sections. There are different types of steel sections in the construction industry, and a good engineer must be able to understand all the types. You have got a T-bar. Okay, you have got a T-bar. This is a T-bar steel section. It only has what is known as, this is what is known as a flange. This is a flange followed by a web. Okay, this is a web, a flange. So a T-bar has got a web, it has got a flange and a web. This curving part between the flange and the web is what is known as a root, also known as a fillet. A fillet. So this is a T-bar section. This is an angle line. I'm sure this is very common in the construction industry. This is an angle line. It has this web and it also has a half flange. It is not complete. It has a half flange, and in between there's that curve which is known as a fillet or a root. Okay, then you have what is known as the HSS section. Okay, others call it square tube. Okay, this is the HSS section. They're of different sizes. Like in the previous picture I showed you, this is what we're talking about. This is an HSS section. Okay, so this is a section. These are steel sections. Then you have what is known as the H section. Okay, H section. The H section has got very thick flanges and the web, thick web, and very heavy. The H sections are heavier and they have got big flanges. If you look at it, it looks the same as this I section. This is an IP section. This is an I section. An I section is quite thinner, okay, lighter compared to the H section. Okay, the H section has got bigger flanges and a big web. And mostly the main uses of the H section is used to carry heavy loads. We're talking about, these are the ones that are mainly used as columns. Okay, mainly used as columns because of their weight and their thickness for the flange and web. Okay, while for the I sections, these are lighter and mostly used for bridges because they can carry loads across a what? Across a gap. Then you have got the channel section. This is a channel section. Looks like a C section or channel section, which has got two half flanges and a web. So these are types of steel sections we have in the construction industry. We can add more. Okay, I thought to add more. You've got the H section, which is the H beam or H section. You can see it's a bit larger and a bit heavier than the I section. You also have the Z section, which looks like a Z from the shape itself. Then you've got the C channel, angle lines. You've got the ripped channels there, channel. Okay, you've got the square tube, also known as HSS. You've got the round bar, reinforced bars. These we know. Then you have got the rail steel. There's the rail steel section, which has got a larger bottom flange compared to the upper flange. Okay, these are types of steel sections. So to these sections now, we need to join a base plate. Okay, so how is this done? You have this metallic shape here. It is known as a base plate. Okay, it's a plate, and on this plate we're going to weld our H section. Okay, we're going to weld our steel section to it. Okay, so that it is linked to the steel section for it to sit. Okay, to sit on the column that we are working on. Okay, so this is a base plate. If you've observed, this base plate has got holes. Okay, these holes are what are known as gouges, and there's a way we gouge them. Okay, there's a gauging process. Okay, in which holes are drilled. That is known as gauging, the process of drilling holes or gouges on what? On base plates. So these base plates, they have different types. I'm going to show you the sizes for the base plates. Okay, so when we are buying IPE sections, you buy according to the size, the height. Okay, the height. If you hear, for example, IPE 200, IPE 180, IPE 480, IPE 720, IPE 400, that simply means IPE with a height of 400, IPE 300, IPE with a height of, and the height we're talking about is the height from the bottom flange, edge of the bottom flange to the edge of the top flange there. Okay, so you purchase them according to their sizes, height, and according to their weight, the meter. From there, we move on base plates. So these are examples of base plates. There are different sizes of base plates, okay? Different thicknesses of base plates, the gauging diameters, depending on when we are gauging these gauging, I mean, these base plates. Okay, let's see the sizes. So when you are going to purchase base plates, you have the MC. I mean, when you are buying, purchasing anchor bolts that you're going to place in these holes, okay, in these gauges that you have made, you're either going to buy, you're going to purchase your anchor bolts M16, M18, M10. That simply means the sizes of these gauges that you are making. Of course, there are drill bits that they're going to use when drilling these. Okay, so the sizes of these base plates differ on the market. Looking at the thickness, if you can see even from the picture, others are thicker depending on where you're going to use them. Okay, so this is the visual. This is the visual. After you buy these anchor bolts, these are anchor bolts. If you've noticed, these are anchor bolts. Okay, anchor bolts which are fastened to the what? They are fastened to a base plate. Okay, once they are fastened to the base plate, okay, if you notice this bottom part is going to overlap, with the RCC, the reinforcement bars in your concrete column. So once they overlap, the protrusion you're going to have, this is overlapping. So you've got your Y16s, for example, inside the concrete before casting. Then you overlap them with your anchor bolts. These you overlap. And once you overlap, you apply your tying wire there. Then you cast. When you cast, this is what you're going to have. So these are your anchor bolts. Anchor bolts which are overlapped inside the concrete there. They are overlapped. And these protrusions, you're going to put your leveling bolt, your leveling nuts on top. You have a washer, then you place your base plate on top. So after you do that, you're going to have something that will look like this in the video. Allow me to play that for you so that you're able to see that. Okay, so I'll be explaining it piece by piece so that you. So at this particular point, though this video started from the start, they're applying gauging there. That is gauging. Okay, so here we start again. So you have your anchor bolts, base plates there. You have your leveling screws that are put there, and it is centered, properly centered, overlapping and casting. After that, you remove your anchor bolts. You have your leveling screws that have remained there. Then you bring your base plate, your steel, which is already a base plate, you place it on top of the leveling screws. After the leveling screws, you place your washers, then on top you have your nuts there. Then you fasten it. Okay? So that is the process of on how we do it. Then from there it's ready to go. So now, so why do we leave these spaces between here? Why these two columns have these spaces here? It's very simple. You want your base plates to sit exactly at 180 degrees. You don't want it to slant at any point. So when you place it directly on the concrete column directly, yeah. If the surface of the concrete column is not properly leveled, that simply means your entire column won't be leveled. It's going to tilt at an angle. It might not be visual, but it is definitely going to do that. In order to overcome that effect, that bending, to avoid that bending effect, you're going to place your steel sections on top of leveling nuts, which are leveled at exactly 180 degrees. The other thing is that you want your force to be evenly distributed through this on the surface of your column. So if it is not properly leveled, that simply means your force is going to be concentrated on one particular point. Okay, it might be on this particular end or that particular end or this other side or the left side. It won't be properly evenly distributed. So to overcome that, you have to place it on top of these anchor bolts as fully seen. So leveling, to have full contact, and also to have your load which is uniformly distributed on the surface. So that was our short lesson on base plate connections, and I hope to see you in the next lesson. Thank you.